Hello students, welcome back to the third part of our chapter Matter in Our Surroundings. So in our previous sessions we have studied that there are three states of matter. Now in this lesson we are going to study about the interconversion of states. So let's see what we are going to study today. So in this session we are going to study the interconversion of states of matter, effect of change of temperature on interconversion. Under this, we are going to study the process of melting, boiling, and sublimation. Interconversion of states of matter. Children, you know that matter can change from one form to other form, or I can say from one state to the other state. So it can change from solid to liquids or to gases. For example, we have seen that water can exist in all the three states. Let's see. Under normal conditions or at room temperature, water exists in liquid form. And if I cool water, it will become ice, or I can say it will turn into a solid. And similarly, if I heat water, then it will convert into vapors, which is a gas. So the water which is at a liquid state can be converted to solid or gaseous state by changing the temperature. Similarly, if I heat the ice, it will change to water, and if I cool the vapors, it would change back to water, or I can say the liquid state. So in this way, matter can change its state. So this phenomena of change of matter from one state to another and back to its original state is known as interconversion of states of matter. The interconversion of states can be achieved by changing the conditions of temperature and pressure. Now let's see how. The change in temperature causes the change in kinetic energy of particles of matter, and hence the interparticle force of attraction also changes, and this causes the change in state. Similarly, the change in pressure changes the interparticle space and hence the interparticle force, which causes the change in state of matter. Now let's see the different terminologies for interconversion of states of matter. So let's see here. When solid changes to liquid, that process is known as fusion or melting. So conversion of solid to liquid is called melting or fusion. And the change from liquid back to solid is known as freezing or solidification. Now when a liquid changes to gas, this phenomena is known as boiling, or we call it vaporization. When gas turns back to liquid, the process is known as condensation or liquefaction. When solid turns directly into gaseous form, then this process is known as sublimation. And when gas changes to solid, this process is known as deposition, or sometimes it is also known as reverse sublimation. let's see what is melting. So melting is a process where a solid changes into liquid at a fixed or a particular temperature. So in melting, solid changes to liquid at a fixed temperature. The process of melting is also known as fusion. Now, what causes melting? So, for melting of solids, we need to heat it. So, when we heat the solid, the kinetic energy of the particles increases. And we know that in solid, the particles are very closely packed. Now, when the kinetic energy of particle increases, they start vibrating with a greater speed. This energy, which is supplied by heat, overcomes the forces of attraction between the particles. Now, we have studied in the previous class that the force of attraction between the particles in solid is very high. So, because of this energy, this force of attraction reduces, and due to this reduction in force of attraction, the particles leave their fixed position and they start moving freely, and this gives mobility to the particles, and due to this a stage is reached when solid starts melting and convert into liquid. The temperature at which a solid melts to become a liquid at the atmospheric pressure is called its melting point. So the pressure should be constant, and we consider it as the atmospheric pressure. So the temperature at which any solid will melt will be known as its melting point. Now different substances have different melting points, because it depends on the intermolecular force of attraction between the particles of that particular substance. For example, the intermolecular force in wax is low as compared to common salt. Thus, the melting point of wax is lower than that of the common salt, because less amount of heat would be required to overcome the intermolecular force, and hence the substances in which intermolecular force is low would have low melting points. Now, one of the important point about melting point is that for any given matter, the melting point and the freezing point is same. Thus, at this temperature, both the states can coexist. So, for example, the freezing point of water is 0 degrees Celsius, and this is the melting point of ice. So, at 0 degrees Celsius, both ice and water can coexist. The temperature would be 0 degrees Celsius only, but we can have ice as well as water both at same temperature. Now, during the process of melting, the temperature of a substance remain constant during the whole process. Now, let's understand it with the help of an experiment. In this setup, I have taken few ice cubes in a beaker, and a thermometer is kept in the beaker to measure the temperature of the contents of the beaker, and it is held with the help of an iron stand. We are providing heat to the beaker with the help of a burner. Now what happens when we heat the ice? It starts melting, and if I try note down the temperature of this whole beaker would be 0 degrees Celsius only, because the melting point of ice is 0 degrees Celsius and it remains constant for the whole process of melting. So till the whole ice melt, the temperature of the contents of beaker will be constant at 0 degrees Celsius. Now let's see, why does this happen? So when we heat the ice, the heat gets used up in changing the state of ice, and the heat is used to overcome the force of attraction between the particles. So this heat energy is thus absorbed by the ice and it doesn't cause any increase in temperature. So that's why it is considered that the heat is hidden in the content of beaker, and this heat is known as latent heat. The word latent means hidden. So the heat which we are providing for melting is known as the latent heat. Now let's see the definition of latent heat. Latent heat of fusion. The amount of heat energy that is required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is called as the latent heat of fusion. So what is latent heat? It is the heat required to melt 1 kg of solid to liquid. So the amount of heat energy which is required to change 1 kg of solid into liquid at its melting point is known as latent heat. And since here the process of fusion is taking place, we call it latent heat of fusion. Now because of this latent heat, the particle of water at 0 degrees Celsius would have more energy than the ice particles at the same temperature. Now we have seen in this experiment that the whole setup would be at 0 degrees Celsius. So there would be some water as well as ice. So the water particles would have more energy as compared to ice because they have absorbed the heat. And that's why we can feel ice more cooler than water at the same temperature. If I touch the ice, it would feel more cold as compared to the water at the same temperature because it has absorbed heat to change its state. Now let's understand the process of boiling. So boiling is the process where a liquid changes into gaseous state at a particular or a fixed temperature. The process of boiling is also known as vaporization. Now what are the causes of boiling? Why does boiling occur? Just like we have seen in melting, we have to heat a liquid to cause boiling or vaporization. Because of heating, the kinetic energy of liquid particles would increase. You know that the liquid particles have kinetic energy more than that of the solids. So when we heat the liquid particles, they would start moving faster. And this energy which we are supplying by heat is used to overcome the force of attraction between the particles. And since the force of attraction is reduced, these liquid particles would move apart or get separated and it would convert into a gas. Now the temperature at which a liquid starts boiling at the atmospheric pressure is known as its boiling point. So again, the pressure should be fixed. The boiling point of water at normal pressure is 100 degrees Celsius. Just like melting, different substances have different boiling points as it depends on the intermolecular force of attraction. For example, boiling point of ethyl alcohol is lower than that of the water. For any given matter, both liquid and gaseous states can coexist at the boiling point. Just as we have seen in case of melting, both solid and liquid states exist at their melting point. So see, in the same way, liquid and gaseous state can exist at the boiling point. So we can say both water and steam can exist at 100 degrees Celsius. So you must have seen when the water starts boiling, vapors are also being formed. So we have both water and steam at the same temperature, which is 100 degrees Celsius. And because of this, now let's understand the process of boiling in detail. Now just like in melting, the temperature of the substance remain constant during the process of boiling. So let's see it with the help of an experimental setup. In this setup, we have taken some water in a beaker and then we start heating it up. And when we heat it, it gradually reaches to 100 degrees Celsius. And at this temperature, it starts boiling and converting into steam. So in this beaker, both water as well as steam is present and the temperature of the system is 100 degrees Celsius. Even if we keep on heating this water, the temperature does not change and it remains constant at 100 degrees Celsius till the whole water converts into steam. So now why does this happen? Again, the reason is same. The heat which we are giving is used up in changing the state by overcoming the force of attraction between the particles. So this heat energy here is absorbed by water without any increase in temperature. So that's why we say that the heat is hidden in the contents of beaker and it is also known as the latent heat. But now here we call it the latent heat of vaporization because here the process of vaporization is taking place. So when melting takes place, we call it the latent heat of fusion, and in case of boiling, we call it the latent heat of vaporization. So now let's see what is the definition. The amount of heat that is required to change 1 kg of liquid into gaseous state at atmospheric pressure at its boiling point is called its latent heat. So this is known as the latent heat of vaporization. So because of this latent heat of vaporization, the steam at 100 degrees Celsius would have more energy than boiling water. And this is the reason that the steam cause severe burns than boiling water. Say if you got burned with steam, then it would pain more or it would hurt more as compared to the burn caused by boiling water because the steam has extra heat which is in the form of the latent heat of vaporization. So this latent heat causes the steam more dangerous than boiling water. Now the next process is sublimation. Now what is sublimation? For this, we take an experimental setup in which we take a china dish which has ammonium chloride. We heat this ammonium chloride with the help of burner. So when we start heating, we see that the ammonium chloride in china dish start converting into vapors. So you get ammonium chloride vapors. Now this funnel is closed with the help of cotton plug. So this helps us to prevent the ammonium chloride vapors to escape out. So the vapors would be present in this inverted tube only. Now as these vapors move up, the temperature of this tube reduces and hence the ammonium chloride gets deposited in this tube. So this here we would get solid ammonium chloride. So in this experiment we see that the ammonium chloride which was in solid form gets converted directly into gaseous form, and then when we cool it, it again solidifies without changing into liquid state. The solid directly gets converted to gaseous state and then gases again convert back to solid. So let's see what we call it. So the process where a solid directly changes into gas without changing into liquid on heating is called sublimation. And the reverse process in which a gas directly changes to solid without changing into liquid is called the process of deposition. So the conversion of solid to gas is called sublimation, and from gas to solid is known as deposition. So there are certain substances which show the property of sublimation. So some of the examples of the substances which show sublimation are camphor or the kapoor which we use for puja, naphthalene balls which we use at our homes in woolen cloths to prevent from insects, then iodine crystals, mint crystal, ammonium chloride, and dry ice. Dry ice is nothing but solidified carbon dioxide. Here the carbon dioxide gas directly gets converted into solid, which is known as dry ice, and this dry ice directly gets converted into the carbon dioxide gas. Now what are the causes of sublimation? Why do we get sublimation? This is because when these substances are heated, their particles move very quickly and they get separated completely and form gaseous state. So there is no liquid state in between. As soon as we heat these particles, they would convert into gaseous state. So this is the reason for sublimation. So children, I hope that you have understood the different processes of interconversion of states of matter. Now you can write the answers of the following questions. So that's all for today's session. Thank you.